Dear students, today we will discuss about the solubility product. Solubility product is represented by KSP. It may be defined in two or three different ways. That the product of ionic concentration, that is the positive ions and negative ions, when they are multiplied with each other. So the product of ionic concentration of positive and negative ions in a saturated solution where ions are in equilibrium with its solid salt. Secondly, the product of ionic concentration in a saturated solution is a constant quantity and is called as solubility product. Or it may also be defined as the product of the ions of a sparingly soluble salt at equilibrium is called solubility product. Now whenever you talk about the solubility product, then there will be Ksp value used for solubility product. Let's suppose the example of silver chloride. When it is ionized, it will form silver ions and chloride ions. Now AgCl, it is present in solid form, while the silver ions and chloride ions which are formed, they are present in the aqueous form. Now, as in earlier lectures I have already told that the concentration of solids and the concentration of pure liquids always remain constant, so there is no need to mention the solids or pure liquids while writing down the equilibrium expression for a reaction. Now if we write down the Kc value for this reaction, so Kc is equal to silver ions multiplied by chloride ions and divided by silver chloride, which is in solute form. So it is the same as discussed in law of May section, that the molar concentration of products divided by the molar concentration of reactants. Now according to rules, the concentration of the solid remain constant, so AgCl will equal to constant. Now we will bring this AgCl along with Kc, as Kc is also constant. So upon rearranging, we will get that AgCl will be multiplied by Kc and the product of the ions of this salt will remain on the other side. Now this AgCl and Kc when multiplied, another constant is obtained, and this constant is basically called as solubility product, which is represented by Ksp. Now there are certain applications of solubility product, in which the first one is solubility of a sparingly soluble salt. We can detect the solubility of a sparingly soluble salt by looking at the Ksp value. When the Ksp value is larger, then greater will be the solubility of the salt, and when the Ksp value is smaller, then lesser will be the solubility of a salt. So you can easily detect the solubility of a salt by using Ksp value. The numerical value of the Ksp is also used to find out the saturation, unsaturation and supersaturation of a solution. Now the first case is when the ionic product is less than Ksp. So in this case the solution is unsaturated and more salt can be dissolved in this type of solution. Ionic product is greater than Ksp, so in this case the solution will be supersaturated and precipitation will occur until the ionic product become equal to Ksp. The third case is when the ionic product is equal to Ksp, so solution is in saturated form and no more salt can be dissolved at the given temperature. Now there are three cases. By using the numerical value of Ksp, you can find out the saturated, unsaturated and supersaturated solution. Third application is separation of salt having different Ksp values. Now salts having different KSP values can be separated from the same solution by addition of common ion. The salt having less KSP value will precipitate first, and the salt which is having greater KSP value will precipitate later. So in this way, two salts when present in same solution form, so the salt with less KSP value will first precipitate out, and you can filter it. You can easily obtain the salt in two separate funnels or two separate beakers. Now